They're asking for the volume of hydrogen sulfide at a particular temperature and pressure that's needed to produce 55 grams of the solid sulfur. They say we can ignore this, assume it's in excess. Now again, they're asking for the volume of a gas, and I only have one way to solve for that. It's with the ideal gas law, nRT over P. They gave us the pressure, 1.28 atm. They gave us the temperature, R is a constant. All we need to do is figure out the number of moles of H2S that are needed. All we were given is that we have 55 grams of the sulfur itself. Well, how many moles is that? Mass 55.0 divided by the molar mass of sulfur, 32.0 something. Maybe it's 0.7 in grams per mole. According to Mr. Calculator, that is 1.71 moles of sulfur. But the question is, how many moles of H2S were required for that? Well, let's take a look. 2 were required for every 3 of these. I needed 2/3 as much H2S as I put in here. Another way to think about that is you could divide by 3, because it's the number of moles of sulfur, and then multiply by 2. I prefer to just think of it as I need 2/3 as much. So all I'm going to do is take my 1.71, multiply it by 2/3, and I get 1.143 moles. That's the number of moles of H2S that I need. I can just plug it all into this formula. I wonder if I have enough room. Probably not. 1.143 moles, 0.08206 for R, 375 Kelvin, divided by the pressure, 1.2 atmospheres. All the units were exactly what we needed them to be. And the answer should be easy as pie. 1.143 times 0.08206 times 375 divided by 1.2. Bam! 29.3 liters. Quite a bit. But then again, we are producing 55 grams of atomic sulfur. And it's at a pretty high temperature. Oh, I almost forgot my units. Liters. Again, when you're asked to solve for a volume of a gas, you basically have to use the ideal gas law, and then you're going to have to know moles, temperature, and pressure to actually calculate it out. The trick here was that they gave you the number of grams of product, which you have to convert to moles, and then figure out how many moles of the reactant you needed to produce it in the first place. In this case, you needed 2/3 as much. Hey, best of luck to you.